This is video number 1 for sections 7.4 and 7.5, completing the square. So during this unit, we have come up with, so far, 2 methods for solving quadratic equations. The first one we did was the factoring method, and then the second one was the square root method. And these methods are both great, but the problem is they don't always work. And so in this lesson, we're going to talk about 2 other methods. These 2 methods tend to be a little messier, but on the plus side, they always work. The first one we're going to consider in this video is called completing the square method. Just a side note about methods as well. You know, in my math lab, they just want the final answer typed in. They're not really checking the method, but make sure you're practicing whatever they ask you to practice, because on the test, I will ask you to show me some of these different methods. Okay, the completing the square method, let me give you kind of a big picture idea of how this method goes. So here's a quadratic equation. It's got an x squared. I just want to solve for x, figure out what x makes this true. Well, you could try the factoring method. I do have a 0 on one side, but pretty quickly you will discover that this thing is prime. It doesn't factor, so the factoring method is no good. You could consider the square root method, but then you notice, wait, there's 2 x's showing, which means the square root method is no good. Well, the idea behind the completing the square method is this. If I can take this piece of this equation and change it somehow so that there's only one x showing, then, of course, I can just use the square root method. So the completing the square method is almost like a preliminary set of steps that allows you then to eventually use the square root method. The big question is, how do I take this thing with 2 x's showing and change it into something that has 1 x showing? Well, to help you understand that, we need to look down here at some patterns. I've written down 3 FOIL problems. These are FOIL problems, right? You cannot distribute exponents into addition or subtraction problems. Why don't you go ahead, pause the video, and work out these 3 FOIL problems. Okay, here's what you should have gotten in each case. These are trinomials. There are 3 terms. And more specifically, they are called perfect square trinomials because they came from something being multiplied by itself. They're perfect squares. Now, if we can create a perfect square trinomial, we then have a way to factor it so that there is only 1 x showing. So creating a perfect square trinomial is really the key here. The main question we need to answer is this. What if I only had these 2 pieces, the front 2 pieces, the ones with the x's, and I needed to figure out what these pieces were down here at the end. In fact, let me get rid of those numbers. I've jotted them down over here on the side so we can remember what they are, but imagine covering them up, and let's say I only had these first pieces. How could I figure out what number goes at the end? In other words, what do you do to a 6 to figure out the 9, or to a -8 to figure out the 16, or to a 10 to figure out the 25? It is a little bit of a tricky pattern because it is a 2-step process. Let me see if I can help you understand. Concentrate on these numbers and then concentrate back on these numbers here, the ones that were in the original FOIL problem. I think it's not too difficult to see that the way you would take these numbers and get to these starting numbers is to simply cut them in half. Half of 6 is 3. Half of -8 is -4. Half of 10 is 5. And then if you look at these numbers and say, well, what do I have to do to these FOIL numbers to end up with those final numbers I was interested in other words, 3 to 9, -4 to 16, and 5 to 25, all you would have to do is square them. 3 squared is 9. Negative 4 squared is 16. 5 squared is 25. Let's summarize then in this box the pattern that we just noticed. What we're saying is, take the coefficient in front of the x. By that I just mean the number that's sitting there in front of the x. We're going to take that number, we're going to cut it in half, and then we're going to square it. That process is called completing the square. It's a way to take these things with two x's, figure out this mystery number to be added on the side so that I can factor it into something with only one x showing. For example, in this top problem, if I follow the steps, I look at the 6, I cut it in half, that's 3, I square it, that's 9. And if I can add this 9 in, then I know that this is factorable in such a way that there's only one x showing. That would work with all of these three examples. Let's scoot down a little bit and try a fresh example here. So the directions here say, take this expression that has two x's showing, complete the square, which just means follow this little box, complete the square, and then factor it in such a way that there's only one x showing. Well, let's see. My coefficient in front of my x is a 12. If I cut that in half, I get 6. And if I square that, I get 36. 36 is the magic number this time that completes the square. In other words, since it fits that pattern, I know that this is now a perfect square trinomial. If it's a perfect square trinomial, I can factor it as something squared. What's the something? Well, you don't really have to put a lot of work into this. If you notice the patterns we had up above, it's always an x. And then after that is simply the cut in half number. Half of 6 was 3. Half of negative 8 was negative 4. Half of 10 was 5. Our cut in half number was positive 6. So this is x plus 6 squared. We completed the square and we changed it so there was one x showing. By the way, if you were in doubt at this last step here, all you'd have to do is go off on the side and work out a little FOIL problem and convince yourself that, sure enough, if you FOIL this out, you're going to get back to what we had. And you would. 6x plus 6x would make 12x. We did it correctly. Okay, so that's the completing the square process. In the next video, I will show you how to use that process in order to solve quadratic equations.